Hello and welcome back to Cracking the Cryptic and another GAS speedrun. And I say that in inverted commas because last time I attempted 5, actually it was 7, genuinely approachable Sudokus. I crashed and burned on several of the first few. So we'll see if that happens again today. There's every chance it will, of course, but I'll be trying to get back on the horse and go quickly through these. These are puzzles all uploaded by Philip Newman, Sam Cappleman-Lynes and Clover to the Daily Sudoku channel on the Discord server, and highly recommended. Worth having a go at that every day just to keep your brain going. They are good fun. They are very good example puzzles of the standard variant types in many cases. So highly recommended, as is our Sudoku Pad app, the last thing we launched. It's available on links under the video or by clicking in the top left when you play one of the puzzles in our software, and it will enable you to download a version of that software to your device and to use that to play classic Sudokus. And we've thrown in a dozen free handcrafted classics for you, and it's only $2 or $3, so it is pretty good value. Along with all our apps, the price per puzzle is about the same on those, and we, of course, highly recommend them. We get lots of great reviews, so honestly, I think they're worth it. They're all on the link under the video, which is where you can find these puzzles. Actually, also, better mention the Patreon murder mystery hunt, cracking the case of the Roman tragedy, which is still ongoing, getting nothing again but rave reviews, and we are getting hundreds of entries in now. The closing date's the 31st of July. So that was free as well on Patreon. So although it's on Patreon, although we'd love you to join our Patreon at $2 or $3 a month and support the channel, that one can be played free if you just go over to the link. Now, let's have a look at the rules of these 5. I'm going to attempt another 5 puzzles today. So firstly, we have Near and Far by Philip Newman. This is actually slightly more complicated than most of the approachable Sudokus in the Daily Sudoku channel. This one is a combination of Renban, so on the purple lines, the digits appearing must form a set of consecutive digits with no repeats. And German whispers along the green lines, any 2 neighbours must have a difference of at least 5. Those are the rules that apply. We'll see how they work together. Then we'll go on to Mathrack Sudoku. Now this is familiar to me from competition puzzles days where this has appeared a few times. Now what each circle does, it has a number and a maths operator in the circle, and that's looking at both pairs of diagonally connected digits and telling you the result of that maths operation on those. So this pair of digits will add up to 10 and that pair of digits will add up to 10. That's how it works. And this pair will multiply up to 16, for instance. Then we will go on to a Palindrome Sudoku by Sam Cappleman-Lynes, in which the only extra rule is that the grey lines are palindromes, which read the same forwards and backwards. Then I think this is a straight thermo Sudoku, although I see all these little thermos daring me to pencil mark them completely at the beginning. I probably won't do that. This is called Ascending Order by Philip Newman. Digits along thermometers must increase from the bulb to the end of each one. And then we've got an Arrow Sudoku with a slight twist. The totals, so those 4 digits add up to the number written into this 2-digit pill, if you like, and that is the tens digit, that's the units digit. So the number is written normally left to right, could be 16, 26 or 36 perhaps there. So those are the puzzles. I'm doing the rules now because I'll hope to just skip between the puzzles one after the other, using the verb skip as though it'll go quickly. That's the hope, if not necessarily the execution. So I will also try and remember, I have about an 80% success rate, to restart all the puzzles so that I know my time when I'm finished. And do try them on the links below the video. Try any one you like, always worth a go. And I'm going to start now. Let's get cracking. So if this is a Renban line, that must be 8 and 9 because they can't appear on the line. That similarly has to be 1 or 9, because this has to be 1 to 8 or 2 to 9. Same down here, 1 or 9 there. This must be 1 and 2. Oh, the German whisper lines are even more helpful. That's got to be a 5, because 5 can never be on a line. And the end of it, that's low, that's low, that's low. The end of it is where 4 and 6 can appear. So we can just do those straight away, I think. That becomes a 9 to be next to a 4. That's low, so it's 3. That must be 8 because it's next to 3. That's the 7. Down here, high, this is low, so that's 4 with 9 next to it. This is 6 with 1 next to it. This is a very symmetrical puzzle, I suspect deliberately. That can't be a 3 next to a 7. So there we go. Oh, and this central column, oh, well, it's all done, isn't it? 9 there next to a 4. 1. Oh, maybe it's not done. 4 and 6 pair at the end. Right, let's have a look at these German whisper lines. This one needs 2 more highs, and that, oh, we know where they go. This is 8, and that's 7, because that end one can't be a 6 this time. So then, oh, neither of these can be a 1. That's a 3, that's a 2, just because of Sudoku. That is 2 and that is 3. There is a beautiful symmetry going on with this puzzle, which I will explain at the end. That's 8 and that's 7. And that's all the whisper line. In fact, I've basically used up all the lines. So the rest is Sudoku. 7 there. That's 3 with a 6-8 pair around it. 7, 9, 2 must go there. That's a naked single 5. That's a 4. 1, this is a 4-6 pair, we know which way round they go. 3, 8, 5 there. Now what, oh yes, that 4 gives us a 6 here. We've got, that has to be a 9 with 2 below it. This is an 8, and to finish off the column, oh, 5 and 4. That's 3. So 4, 2, 7 up here. 2, 7, 4. That fixes the 5 and 4 pair. 6 and 8, yes, they can go in. 5 there and a 2, 7 pair next to them. That 8, 9 pair is done. Let's just work down the columns. Actually, no. 3, 8, 5, they're all done. 9 and 6 resolved there. 3 and 5, yes. 1 and 4 to go. No mistakes needed at this point. 4, 7, 9, 6, 5, 1. That completes box 4. 2 and 7 to finish box 1. And 2 more pairs to finish box 7. There we go. 3.5 minutes. So, I mean, that's really just due to my familiarity with German whispers and Renban lines, and these 2 lines especially are incredibly helpful, especially combined with the knowledge that 6 and 4 can only ever be on the ends of lines, except if they go diagonally between boxes. Let's not get into that. For this puzzle it doesn't matter. But the symmetry I was referring to is from the fact that if you take any pair of rotationally symmetrical digits, they add up to 10. So 3 and 7 there, 9 and 1 there, 1 and 9 there, for instance. You can do that anywhere in the puzzle and they will add up to 10. I suppose for the central cell you add it to itself. And that often gives these lovely combinations, and it's very elegant how Phillips managed to use that to give a given sequence of 1, 2, 3, 4, 5, 6, 7, 8, 9. Anyway, enough about that one. Let's move on to Mathracks by Clover, and remember to restart. And we get some numbers in the circles, which is unusual. So that's a 9, just basic maths to make these operations work. That's got to be a 3, that's an 8. Now 16 here, we can't put 2, 8 in those in any combination without breaking the normal rules. So That's a pair of 4s. That's a pair of 3s. This must be 2 and 4, but we don't know the order. That's 2 and 4, and we do know the order because there's 2s looking at that cell. We don't know about that. This is 1 and 6, and we don't know the order. This is 1 and 6, and we do know the order. And that fixes this 6 and 1 over there. These now have to be 3 and 7. Yes, we do know the order there as well. Then we've got a 6-8 pair in the corners. This 2 is seeing that, so it's fixed it. 6-3 there, can't go there. So they're write-ins now. 8 and 9. Box 1 is just finished. It's resolved box 3. 5-4 pair can't be there, so again they can just fill in. Wow, and we're left. We're going to finish off this box, I'm sure. 8 is a naked single. So is 7. That's on the 11. And now we're just left with these 2 10s. That's a 6-7 pair. This is a 5 to finish the row. 1 and 3 can be filled in there. That's not a 3. That's a 3. That's a 3. Well, we must. This is 1, 2, and 8, 9. Yes, there's a 1, 2 pair there. 8, 9 opposite them. This is a 5. 5 can never be on a 10. So 5 goes there. 7. 6, 8, 9. 1, 2, and 4. That can't be a 4, so that's not a 6. That's not a 9. That's not an 8, so that's not a 2. And those are not resolved, which is a surprise. Right, 6, 7, 8 there. That's a naked single 4. 1 and 9. 5, 7, and 8. And 2, 6, and 9. Oh gosh, what? Oh look, that 9 sees this, right. 8, 9. 2 there, 1 there. The 9 looks across to that, is an 8. So now we can use the 10 in the circle. 2 there, 4 there. Don't make a mistake now. 7 and 6. 2 and 5, forming a funny little deadly pattern there. 7 and 4. 1 and 6. And these must all be... Yeah, that's 5, 8, 7. Yes, they are disambiguated. 2, that 6, 9 pair isn't, but it'll get done by this numbers up here. 8, 7, 6. This has gone well again. 6, 9. And there we go. That's 3.5 minutes as well. So, wow. There was a certain amount of symmetry there, but not quite in the same way as Philip's puzzle, but good fun. And it is nice to see a Mathrax puzzle which you can just go at, because I've spent so long trying to break into them before. Now, on to Palindrome Sudoku, remembering to restart, and let's go. 1, 2, 3, 4, 5, 6. So 7, 8, 9 go in those cells. On the it must be 8, 9 on the palindrome. So that's resolved a 7 up there. 5, 4, 1. Those are from 2, 3, and 6, so those must be as well. Oh, well, these are 7, 8, 9, and yes, symmetry again. 7, 8 there, must be 7, 8 there with a 9 in the corner. These are from 1, 3, 4, so are those. Oh, hang on, this is on the end of the palindrome. So it sees 7, 8, 9, 5, 6, and up here it sees 1, 2, and 3, so it's a 4. And this, I bet we can do this. 4, 5, 6, 7, 8, 9, 1, and 2 there. So it's not working quite as symmetrically. Sam's been a bit cunning here. 2 there, we get a 1, 9 pair. This is 5 and 6, I can fill them in. That's a 3, 4 pair, I can fill those in. That's a 1, 2 pair, which I can't. That's very weird. 5 there, 6, 7 pair. Now, oh, 3 is hasn't been able to be those for a long time. So 2, 6 pair, looking at that 1, 2. These are from 7, 8 and 9, and that must be as well because it's on the palindrome. Those can't be 4 anymore. That's a 2, 6 pair that can go in. That's a 1, 5 pair that can go in. 7, 8, 9 there and there as well. That can't be 7. 7, 2, 6, 4, 3, 1. 3 and 1 are resolved, and that's on the palindrome. 3 and 1. I've got 6 and 2 resolved, yeah. 6 and 2. Still haven't got... I've got an 8, 7, 9 triple there. Right, that puts 6 here and 1, 4 up there. That is very helpful. 3, this 6, 7 pair's done. Still haven't done this 8, 9 pair. That's not 9. Oh, that's 7 or 8, so 2 goes there. That can't be 7, so 1, is it, that goes in here? Yes. 3 must go there. And we've just got these sort of weird 7, 8, 9 triples everywhere, I think, to resolve now. 5 or 8 there, 9. No, I didn't mean, hang on, what did I mean? Let's go back. That is 5 or 8. That's 8 or 9. This is 5, 8 or 9. Sorry, I'm misreading that triple. That's a naked single 4. I can do 5 and 6. So 5 is not there. That's 8. That's 9. That's 5. That's not 8. So that's not 8. Oh, this is 7 or 9. This is 4. They're looking at that. So that 8, 7 is fixed. That can't be 7, and that can't be 8, and that can't be 8. I've got these triples now. Oh, that's a 7. So 7 there, 9 there, 8 there. So these are all resolved. These have to be the same because they're on the palindrome, and they can now only be 9s. Yes. 8, 7, 7 there, 8 there. And just over 4 minutes this time. Well, not too bad at all, though. That's just a romp, really. That's nice. A nice setup from Sam. I like it. Right, let's carry on. This hasn't been going too badly. Well, pride comes before a fall. Let's have a look at this thermo with the short thermos. Let's restart. And 6, 7, 8, 6, 2. That's 3 or 9. That's 1 or 2. I'm not seeing any actual write-ins in this, but maybe I'm just missing stuff. Hang on. Yes, this bulb sees 1, 2, 3, 4 and 5. Yes, it does. So I can pencil mark a short thermo usefully, I think. 7, 8, 2, 9. I don't know, it doesn't give me anything else. What about this? This isn't the same because... Oh, hang on, maybe it is. This sees 5, 6, 7, 8 and 9 on the end. So 3 or 4, 2 or 3, 1 or 2. Is that right? Yes, it is. I don't know, though. It's not giving me any triples and quadruples. Oh, that's 1 or 3. Is there some X-wing going on or something somewhere? I don't know. It feels like there is and I can't see it. That's 1 or 2. One of those is 1 or 2. That doesn't stop that being 2 or that being... Oh, that can't be 1. What about these? They look unusual. 1 and not 1 is in one of those positions, and 9 is on one of those ends. These thermos are so short and unhelpful. You know that, Philip. One of those is a 1. That doesn't seem that interesting. 8 has to be in one of those 2 cells, doesn't it? In box. No, it could be there. No, it can't be there because of that 9. Oh, look, this sees 1, 2, 3, 7, 8, and 9. That is 4, 5, or 6. And this sees 1, 2, 3, and 6. So this tiny thermo is worth pencil marking. It looks incredibly helpful. Now, that has confined 8 to one of those 2 cells. So now that can't be 8. What about this one then? Symmetrically opposite. 2, 3, 7, 8, 9, 1. So that's 4, 5, or 6. This sees 8, 4, 9, and 7, but it's higher than 4. So it's 5 or 6. It can't be any higher than that, I don't think. No, it can't. So, sorry, this is now not 6. Sorry about the noise. That will get resolved in a minute. 4, 5, or 5, 6 there. I mean, there's not a lot of choice, but I don't quite know what's actually going on. So, what about this one then? This can't end in 9 or 8. It just doesn't look so helpful. But this would form a quadruple if this has to be... Yes, this has to be below 7, and it can't be 5 or 6, so it is a quadruple. Surely that's going to do something. 1, 2, 3, 4. Yes, that stops this being a 1, and now the only place for 1 in the row is here, and there is an X-wing on 1s, and I've just spotted it. It was in those cells. So this has become a 3. That's a 1. This is 9. That's 2. Oh yeah, that's not a 9. So we've got a 7, 8 pair. That's now a 9. I don't think I can resolve that 7, 8 pair, surprisingly. 1, 2, 3, 4. Yes, I can, because this is a 7 now. Remembering that quadruple. That fixes that as an 8. That's not a 7. I don't know what this is, though. 3, 6, 9, 2, 1 must be there in this box, which fixes 8. These are from 4, 5, and 7, but this can't be 1, 4, 5, 2, 9. It's 3. It can't be 3. It's a 6. Must be 7. So that's fixed this thermo. This is very elegant, this puzzle, isn't it? 4, 6, 4, 5. That's a triple up there. 2 and 9. That can't be 7. Is this not resolved? No, I don't think it is. This now can't be 1 or 3. Never could have been 3. That has to be bigger. 9. I can place 9. That can't be 7, so 7's there. Oh, the symmetry's disappeared suddenly. Oh, this can't be 1, so that's 1. This can't be 9, so that's 9. That does fix the 2, 9 pair up here. That 2 fixes this as a 1, which I could have done anyway from that triple. Didn't see it. Oh, come on, this must be finishing now. 6, 1, 7. They're from 3, 4, and 5. Oh, come on. 9. 9 goes there. 5, 6, and 8 to place in the column. Surprisingly not that helpful. What about this row? Column, I mean, 73198. I don't know. It's not all that, is it? Okay, 7 can't be there or anywhere here. Can that be a 7? Well, wherever 7 is, 8 is going to now have to come after it in one of those two places. So 8 can't be there, and it also can't be there. So I can place 8 in the middle box. That's weird. I can't believe that was necessary, but it was fun. 3, 4, 5, and 6 still to go in the column. It was fun, but it doesn't seem to have got anything done. All I know is that 7 and 8 go together on one of those. What's this? No idea. Wow, how is this not falling? 9, 8, 5, 3. 7 has to be in one of those. Can't be there, obviously. So one of those two is a 7. 7 is either there and there, or there and there, and they both seem plausible. Right, these are from 3, 4, 5, and 8. That looks quite interesting on the right. One of them has to be the end of a thermo. So this cell, in one of these cases, is 2 or 4. And then we have a 2, 3, 4, 5, 8 quad. Good grief. Is that right? One of these has to be... No, that's not right. Because you'd need a quint, wouldn't you? No, calm down. 3 and 8 are definitely in those cells, and that one can't be 8. Oh, sorry. 3, 4, 5. So 2 and 7 are here somewhere. That doesn't really help. What am I missing now? 9, 8, 7, 5. That's 1, 2, 3, 4, or 6. Reduce to pencil marking 2 cell thermos. The humiliation. 1, 7. If that was 5, that would be 6. That would be 5. We'd have a 3, 4 pair in the central box. They can't be 4. This is a 2, 3, 5, 6 quad. Is there some sort of stacking thing going on? Yes, look, that's a 2 because that's a 3, 5, 6 triple. Yes, it's not a stacking thing. 2 there, so this central bulb's fixed. Gosh, that took forever to spot. Very clever. 3 can't be there. So we've got a 4, 5 pair now in the row. So 9, 3, 8, 4, 5. The only place for a 1 in this row now is here. In fact, that's the last, almost the last one in the grid. That is the last one. I'm still not done. 9, 7, 1, 5. No, let's look at this central box. That can't be 3 or 5. 2 has to be there from 2, 4, and 6. 2 is definitely in one of those cells. That can't be a 5. 7. No, that just tells me 7's in one of those two. It's like an X-wing of 7s. 8 is probably an X-wing of 8s there, yes. Oh, 4, 5 pair, right, so that's a 3, 8 pair. And that makes this a 6, and surely that, well, it gets the column done. Yes, that fixes this as a 4. That makes this a 3. Now the thermo finally helps there. Yes, 5, 3. So the bottom 3 boxes are done now. 2, 4, and 7 go in these cells. So that's a 5. That makes this a 4. And that resolves this triple at the top. These have been resolved by the 5 at the bottom. That becomes a 4. This is a 2-6 pair. I really don't want to still be wondering what's going on in the middle row after this, but who knows? 3, 9, 4, 1. 6 and 8 are a pair there. 6, 8, 4, 9, 3. So 2, 5 and 7. In fact, a 2, 7 pair. That's a 5. And my exact fears are coming true. No, 4 can't be in those. So that's a 4. Now we can use this tiny thermo. It's brilliant. 6 and 8 there. 8 goes with the 7 I worked out ages ago. 7 and 2, that's a 3, that's a 6, and we are done. And that was much harder for me. 12 minutes 42, crumbs. Well, I mean, I was probably a bit dim around some of that, but looked like we had to get that quadruple to start with. Maybe not. Then I was a bit slow on the middle column. That's definitely true. I could have done a lot more with that. Maybe it would have helped to spot that X-wing on 1s earlier, rather than only when I had actually unraveled it a different way. Anyway, let's have a look at the Arrow Sudoku now by Clover. Finally remembering to restart this. And right, this middle row, 36 plus 6 plus 3 makes 45, which is the secret of everything. Oh, look at this one. The maximum this can be is 19, and the minimum this can be is 19. So we get a 1 there, a 3 there, and a 2, 4 pair. Oh, of course, and these add up to 45, so these 2 pills add up to 45, and that's a 26. We've got to get a 6 on the line, plus 5, 8, 7, and they're all done. Right, so these 2 add up to 45 in just the same way. That's an 8, and that's a 2, and now they do. So this makes 80... No, this makes 27, so we get 9, 8, and 7 on this arrow. 7, 8, 9. 2 and 4 must be here. 1 and 6, yeah, they can be filled in. I can do those now on the top row and bottom row, and all the pills are done. So the rest is classic Sudoku, I think. 5 there, flanked by a 6 and 7. That's a 3, it's the only place it can go. That's a 9, flanked by a 1 and 4. We get a 2 there. 4 must be there with a 5, 7 pair that I can't resolve. That's a 4. Oh. I don't know what that is. I thought I would. 1 with a 5, 6 pair around it. That's where 8 goes. This is a 7, 9, 3 triple. They can be done. We get a 6 here. 5, 9, and 3. So they can be filled in. That's fixed the 7, 5 pair. That's 4 and 2 in column 2. 3, 8, and 6 in column 8. I still don't know which way around they go. That's annoying. 1, 2, and 4 in column 7. Oh, that's a 1. Just to complete the column 5. 5, that's 6, 9, 5, 8, and a 2, 7 pair that I can't resolve. 9 and 5 in row 6. That's fixed the 6, 5 pair, which fixes the 6, 7 pair. That is an 8. 9, 7, 2, 7. That's a 4. That does the 1, 4 pair. And we're just left with 1 pair to do. Good grief. 1 and 2. That is approachable. That's a really nice puzzle. You just need to spend a little moment. What's that? Just under 3 minutes. A little moment thinking about the sum of 45 there. And then these pills are all very completable straight away. Now, I was familiar with the fact that the only way to have an arrow of this shape in a row is with 36 on it. So that did help as well. But really nice puzzle by Clover, and a really good introduction to Arrow Sudoku with 2-digit numbers, frankly. I enjoyed that a lot. So brilliant. That one's gone a lot better than the last speedrun attempt at Sudoku, but still a bit tripped up, I think, by this ascending order. Really nice puzzle by Philip Newman. Intriguing. I mean, I probably missed at least one of my party hats, which are the awards for speed solving in these puzzles there. I reckon I'm going to be about 9 out of 10 on this one, though. So, most enjoyable. Thank you, as ever, to Clover, Philip, and Sam for continuing to prepare these puzzles. They're incredibly helpful to loads of us, frankly, myself included, and very enjoyable solving. Thank you, as always, for watching us on the channel, and I hope to see you again soon. Bye for now.